Hi Evergreen, we're going to do chapter 9, lesson 5, the Pythagorean theorem. I'm sure you've heard about this before. And looking at this picture, I'm sure you can kind of give a little hint of what the formula might be. And so we have a triangle, and then we have this side being c squared, the shorter leg being a squared, and the second leg being b squared. Okay, let's dig in. So, Theorem 42 says the Pythagorean theorem. The square of the hypotenuse of a right triangle is equal to the sum of the squares of its legs. So, this is our triangle. It is a right triangle. A is a leg and B is a leg. So, these are the legs. And C is our hypotenuse. Hypotenuse. And so it's saying that the square of the hypotenuse is equal to, so this hypotenuse is C squared, is equal to the sum of the squares of its legs. So it's equal to one leg squared plus the other leg squared. This is your Pythagorean formula, and this is your Pythagorean theorem written in words. So these all have to do with a right triangle. So many proofs have been developed for the Pythagorean theorem, in fact, more than any other theorem of geometry. Our proof, based on area, is one to which you were introduced in chapter 2, long time ago. So, given that this right triangle ABC with legs A and B and the hypotenuse C, prove that C squared equals A squared plus B squared. So, we are going to be proving this with this theorem. Read and follow along with me. Construct a square DEFG. DEFG. Okay, do we see that? Yes. And with the sides of length A plus B. So A plus B is making this length of their big square. Okay, we've done that. Now, let's look. Draw lines to divide the square into 4 right triangles and a quadrilateral as shown in the figure to the left. So we have created little triangles, 1, 2, 3, 4. These are equal to this triangle right here, ABC, because it has the same side lengths of A and B, A and B. And then we connect the lines for C. A and B, connect the lines. A and B, connect the lines. A and B connect the lines. And when we do that, it creates a square in the center. And they've named this HIJK. And they added little squares to show that these are right triangles that are formed. Okay, so the 4 triangles are congruent to triangle ABC because side, angle, side. They had 2 sides that are the same, and they had an angle that was the same with the right angle. So the length of each side of the quadrilateral, HIJK, is C. Yes, because C is the hypotenuse of each of these 4 triangles. So we have C, 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 C. I'm going to go ahead and write that. C, 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 C. Do you see how we have created 4 of our original triangle? And we have created a square in the center with each length being C, which is equal to the hypotenuse. Okay, so now we have a clear understanding. Let's keep going. If X and Y are the same measures of the acute angles of triangle ABC, then X plus Y equals 90. So what they're saying is X and Y, X, and Y equal 90 degrees. And we know this because all of the angles inside of a triangle have to add to 180. If we know that C is 90, therefore we know that x plus y must equal 90 because 90 plus 90 equals 180. Because the acute angles of a right triangle are complementary, numbering the angles of the quadrilateral HIJK as shown in the next figure at the left, we have, here we go, see how we have the angles here, x, y, x, y, x, y, x, y. We have angle 1 equals angle 2, yes, and angle 3 equals angle 4. And these all equal 90 degrees. Oh, I skipped a line up here. X plus angle 1 plus y equals x plus angle 2 plus y. Let's see, yes. So here, these three angles here add to 180. These three angles here, x, 2, and y, add to 180. X plus 3 plus y adds to 180. That's what it says here. And then last, x plus 4 plus y adds to 180, and each are equal to each other. And so now we know that angles 1, 2, 3, and 4 are equal, and they must equal 90 degrees because we said that x plus y is 90, and a line in total has to equal 180 degrees. And so therefore 180 minus 90 degrees gives us that these angles each equal 90. So because HIJK is an equilateral and equal angular, it is a square. According to the area postulate, the area of an entire figure is the sum of the area of its parts. Yes, we already learned that. And so A plus B squared, oh, now we're going up here, A plus B squared. So this is a square. So we're basically saying length times width, base times height for the area of the square. But instead of saying base times height, we're saying A plus B squared equals 4 times 1/2 B squared. So this is our 4 triangles here in the corner, plus C squared plus our square in the center. So this entire square is found by adding the sums of the 4 triangles and the sum of the square. This is what we have. When we do this algebra and we simplify this expression, we distribute this all and we simplify, we end up with the Pythagorean theorem. C squared equals A squared plus B squared. Very good. And so we only need to talk about one more theorem, and we have learned this entire chapter. Okay, theorem 43, converse of the Pythagorean theorem. Converse. What does this normally mean? Converse normally means the opposite, right? So if the square of one side of a triangle is equal to the sum of the squares of the other two sides, the triangle is a right angle. So basically it's saying that if this is ever true, therefore it is a right triangle because the Pythagorean theorem only works with right triangles. Okay, great job.